So today we're going to talk about completing the square today. So before I talk about, this is actually another method of solving a quadratic equation. Turns out this is very useful and powerful actually when you're dealing with quadratic equations. So before I talk about completing the square method, let's talk about perfect square trinomial. Okay. Do you guys remember PST, perfect square trinomial? So what do I get when I multiply x plus a, the whole thing squared? You get a perfect square trinomial, don't you?
Yeah.
Does anybody remember what we get when I multiply this binomial square? Yeah.
I get x squared plus 2ax
Good.
plus a squared.
Good. You guys remember that? If you don't remember this is, we just multiply it out, right? So if you multiply x plus a times x plus a, well, x times x, you get x squared. How many xa do we get? Here you get one of them, here you get two. You get the same one because you're multiplying the same binomials, right? And then you get a squared at the end. Right? And that's your, this trinomial, right, is a perfect square trinomial, right, guys? What if I have x minus a squared? What do I get if I have x minus a squared? Anybody remember? Yes, Laura?
X squared plus a squared? Oh, never mind.
No. If I have x minus a squared, you get, instead of x squared plus 2ax, you get is x squared minus, exactly, 2ax. If you don't believe me, you can multiply it out, right? So, here. An anti-trinomial called perfect square trinomial, right? The perfect square trinomials are, you get perfect square trinomial from multiplying binomials together. You guys remember? So write this down if you forgot about it. So let me ask you this question. So instead of giving you a binomial to square, what if I have part of a trinomial, and if I ask you what number do I need in here so that this trinomial becomes a perfect square trinomial, do you think you could figure that number? Do you think you can find that number? It's kind of working backwards. You know what I mean? Go ahead. I want you to think about this as a group. Oh, you already have the answer? Hold on. Think about it as a group. Yeah, what's your question?
X squared minus 20?
Yes, it's x squared minus 20x. Go ahead. Okay. So now that you thought of this, alright. Okay, time to listen now. Okay, Malia, what did you get? What did you guys come up with? This is your group. Here we go. Let's listen. Let's listen. Oh, okay. Go ahead. You said 100? How many people agree that you need 100 in there? Very good. You are correct. Now, so then that trinomial is a perfect square trinomial, isn't it? So if this is a perfect square trinomial, then what is the square of what is the binomial that we're squaring? Anybody? In other words, how do we factor this? Yeah, Derek?
X minus 10 squared.
Correct, x minus 10 squared. Does that make sense? And this is kind of nice and kind of easy to figure out because of the leading coefficient of the x squared is 1, right? The leading coefficient of this, right? If that wasn't 1, it may not be this easy. Can you do another one then? What if I give you this trinomial? What needs to go in there? Again, it's the leading coefficient is 1. X squared plus 14x plus what becomes a perfect square trinomial? Oh, you already, okay, well, go ahead, do it. I'll give you some time. Okay. And help each other out, okay? See if you, okay, who thinks they know what number we need in there? How about Shrock?
49.
49. How many people say 49? You are all correct. Very good. So then if this is now a perfect square trinomial, this is then a square of a binomial, right? Which binomials do we need here? Judy? X plus 7 squared. Good. Does anybody see any pattern in terms of figuring out what that last number is if the coefficient of the leading term is 1? Andrew?
You just go to like 14 and then you divide by 2.
Yeah.
And then you get 7 and then you multiply 7 by 7.
Yeah. You divide that number by 2 and then square it, right? Well, and it's kind of interesting. Look, when you write this as a squares of binomial, right? You get x plus 7. Where did we get that 7? Well, that's just half of that 14. And then where did we get 49? You square that 7, right? Here, what's that number in the middle? Is this negative 20 or 20? What's that b, in other words? What's b right here? Negative 20. So when you do negative 20, well, divided by 2, isn't that negative 10? So you get x minus 10 squared, right? And what's negative 10 times negative 10? 100. Do you guys see the pattern? Does that make sense? Yeah. So this is always going to be true if this was easy because of the coefficient of the leading coefficient is 1. If it was not 1, then it's not going to be this easy. Does that make sense? Okay, so keep that in mind. Now, let's see if you could actually do this for a general formula here. Okay. So if this is true, so instead of having some number like 20, negative 20 and negative 14, what if I have some general b, right? So what will be the general formula for this? What do I need to put in here then? Anybody have an idea? Well, let's do, how about 1, 2, 3 people? Think about it as a group. I'll give you time. What do you think I need to plug in here and here also? 2 places. This one, guys, listen. This one and this one. What needs to go in there, okay? Think about it. Go ahead. Who sees the pattern? What do I need to put? How about, yes? 1/2 b squared is correct. In other words, b over. Good. How many people agree? Yeah, it looks like it works, right? 14. What's 14 over 2? 7. What was 7 squared? Here. What's well, this is b is negative 20, right? Negative 20. So what's negative 20 over 2? Negative 10. Negative 10 squared is 10. Then 100. So what do I then put here? What needs to go in there then? 4 people? Yes. How about, yeah, Sierra? Yeah, b over 2 is exactly right. Isn't that right? Look, how do we get to 7? Well, what's 14 divided by 2? What is negative 20 divided by 2? Negative 10, you see how it works out? So this is always going to be true. Now, this was easy because, again, the coefficient, the leading coefficient is 1. If it wasn't 1, it won't be this simple. Any question? Okay, so why are we doing all this? Well, you see why in a minute. So keep that in mind. Hold on. Let's move on to the next example. By the way, could we verify that this is true? Yeah, multiply this, right? Multiply this out. X plus b over 2 times x plus b over 2. How many b over 2x do we get? 2 of these. When you have 2 of these, well, doesn't that equal to just bx, right? Yeah. And then what's, well, you get b over 2 squared, right? Here. Does that make sense? So you could always verify. By the way, this process of figuring out this b over 2 squared is called the completing the square. Okay? So on your homework tonight, they're going to ask you to complete the square. And do you know what to do then if they ask you to complete the square? Yeah. You're trying to figure out what this number is.
Oh, I can see it.
Okay? Oh, sorry. Well, you're trying to make it so that, you know, the trinomial becomes a perfect square trinomial. Does that make sense, Judy? That's why it's called completing the square method. You know, you're trying to make it into a perfect square trinomial. Right? Does that make sense, guys? Okay. So the next example says, look at the instruction. It says to complete the square, and they have this place for you to fill something in. And once you know that, then you know what to do. You know how it's going to factor, right? Go ahead. See if you could figure out this with your group. Now, notice that this is the same exact problem as before, except now your b happens to be an odd number. So that's the only difference. Everything is all the same. Okay, go ahead. Everybody try. See what you get. Put things they know. Now, once, by the way, as you're trying this problem, when b is an odd number, it's not so nice as when it's even, right? Because you're going to have to do what? I don't like decimals. You have to, yeah, you're going to have to use fractions. Okay, but it's not a big deal. Can somebody tell me what I need to put down here? What goes in the last? Let's see. Ready?
5.5 squared.
Right. I'm just going to leave it as improper fraction. Do you mind? Okay, so then, of course, did you all say it's 11 over 2 squared? Yeah. There you go. And of course, then it becomes x plus 11 over 2, the whole thing squared. Would you not agree? Okay. So what is 11 over 2, by the way? You should just, let's simplify this. Yeah, 121 over 4. Okay. But do you see why I left it as something square this way?
Yeah.
Because it's easy to see. I know what goes in here, right? And what goes in here. You guys see that? It's the same number. You just, on the left side it's going to be square, of course. It's going to be the binomial square. Any question? Just easy? All right. Good. So if I ask you to solve, then, so here's the reason why we did all this work. I'll show you in a minute. By the way, if I ask you to solve this trinomial equals to 0, x squared minus 24x plus 23, is this an easy problem or hard problem?
Hard.
Easy. This is actually easy. Why? Raise your hand. Raise your hand. Who knows what to do? If I ask you to solve this, all you have to do is what? Anybody? Yeah, you factor, right? You use the zero product property. This is already set up so that it equals to 0, right? So is it easy to factor this trinomial? Yeah, because look at the leading coefficient. It's 1. So you're really thinking, what two numbers can you multiply? Right? That multiplies to 23, and then when you add, you get negative 24. Anybody know such number? Yes. Yeah. Exactly. Negative 23 and negative 1, right? Don't you get then, when you multiply negative 23 times negative 1, you get 23. When you add them together, of course, you get negative 24. And so when is this true? Well, of course, this equals 0. When is this true, Anais?
We just do like the x minus 23 equals 0 or x minus.
Exactly. This will be true when, by using the zero product property, each of these factors will be 0, then the whole thing will be 0. When is that true? When x equals 2?
1 or 23.
Exactly. Okay, any question? Right? So if I ask you this question, just solve, you'll be done like this, right? But on your homework, it's going to say this, by completing the square method. Okay. So I'm about to show you how to do that. In other words, there's actually another way of solving this sort of equation without factoring. Okay? This is called completing the square method. Okay? Are we okay? So are you ready to learn this new method?
Yeah.
Okay. By the way, when I use different way of solving this equation, to solve this equation, do you think I should get the same solution?
Yeah.
Yes, as before. It better be, right? Because as long as it's correct method, right? Does that make sense, Andrew? Okay, so what I'm going to do, Andrew, is first of all, I'm going to start with this equation. And what I'm going to do, so here's another way of solving this, okay, Elizabeth? So what I'm going to do is, since I know that my coefficient of this x squared is 1, I say, wait a minute, this will be really nice if the left side, this trinomial, is a PST, perfect square trinomial. Is it a perfect square trinomial, Elizabeth? No, it's not. Okay. What makes it so that it's not a perfect square trinomial? What's kind of... Yeah. 2? You see 2? I don't see any 2.
Oh.
The 3 looks like a parentheses.
Oh, no, this is 23. So you mean 23, right? Yeah, sorry. The number 23 is, right, the one that's kind of causing it, right, not to be a perfect square trinomial. Does that make sense? So, guess what I'm going to do? I'm going to get rid of that 23 on the left side. Is there a way to do this? Yeah, since you have an equation, all you have to do is subtract 23. And you say, and then you ask yourself, okay, now that number is gone, I now have x squared minus 24x. Let's complete the square, meaning let's add a number right here so that the left side becomes a PST. Is there a way to figure out? We just did this, right? Yes.
You divide negative 24 in half, which would be negative 12, and then you square that.
Exactly. You just do b over 2 squared. Isn't that how you complete the square? So what is b, class, right now? Is it positive 24 or negative 24? Negative 24 over 2, which is negative 12. So I'm going to add that to the left side. Hold on. So that's what I just did here. I added that b over 2 squared on the left side. By the way, if I add something to the left side of an equation, can I just leave it like this? Would this be correct? Why not, Shra? Why not? Why can't I just add negative 12 squared to the left side? If you have an equation, can you just add one number to the one side only? What do you have to do then? Yeah, you have to add it to both sides because it's an equation. Left side is equal to the right side. So if I'm going to add negative 12 squared to the left side, guess what? I better do the same thing to the right side. Okay, so don't forget that, right? You can't just add one. But why in the world do I do this? What's the point? Well, Christine, do you see what happens on the left side? Now, that trinomial is what, Christine? it's a perfect square trinomial, right? Does that make sense? Kristen, then what do I get? If that's a perfect square trinomial on the left, it becomes?
X minus 12.
Exactly. Doesn't that become x minus 12 square, class? What about on the right side, Aaron? I have negative 23 plus, what is negative 12 squared, Aaron, by the way? Yeah, so you get 144 plus negative 23, which is? 121. Now, does this look familiar?
Yes.
You have a perfect square equal to a positive number. Didn't we learn this last time? Yes, from yesterday. So, okay, hold on. So, Caroline, if I have, guys, listen. If I have something squared equals to a positive number, guess what I'm going to do? Square root both sides. Go ahead, everybody try. See what you get. Go ahead, everybody try. Do you think you should get the same answer as before? Yes? Because if you're doing it correctly, you better get the same solution. Right, Shra? Go ahead, everybody try. I'll give you some time. Help each other out. See if you get there. So, Lindsay, what did you guys do next? Let's listen now. This is time to listen. Go ahead. You square root both sides. How many people square root both sides? And remember to put plus or minus. Good. Because if you don't, you're not going to get two solutions like before. Okay. By the way, look at 121. Isn't that a perfect square?
Yeah.
What is that perfect square of? 11. Okay. So I get x minus 12 equals to plus or minus 11. Okay, Harrison, what do I do next?
You move 12 to the other side.
By?
Minus
No, you have x minus 12, so you have to add 12 to both sides. So you get x equals to 12 plus or minus 11. Now, let's write down the solution. How many numbers does this represent? 2. Let's write down the smaller one first, because we like to write things in order, from smallest, increasing order. Go ahead. Anais?
Don't you get the same answer?
Yes. You better. Because if you don't, then you did something wrong. What's the answer, guys? You get? What's 12 minus 11?
1.
What's 12 plus 11? We get the same exact answer. Right. And you might say, Mr. Huang, why do we do it this way when, didn't we do it a lot easier when you factor this? Right? This was a little bit longer than the first method. Now, hold on. So as a group, I would like you to think about this. You need to see why this is actually a really powerful method. Think about this, okay? Go ahead. I would like you to think about it as a group. Why do you think this method is important and is powerful? Go ahead. Why do you think it's really powerful? Who thinks they know why this is really a very powerful method? Yes, one person. Go ahead.
Oh, like, what if the quadratic thing on the right, left side is like not a good thing?
What do you mean?
I mean, like, what if it's like really like hard to factor? It's not like the numbers are like ugly.
So take a look at this example 4. Listen. If I gave you this example 4, and you say, well, Mr. Huang, why don't we just factor? Can you factor this trinomial?
No.
This trinomial is not factorable. If you look at it here. I tried, how many ways are there to get 3x squared? There's only one, right? 3x and x, right? How many ways are there to get negative 1? Positive 1 and negative 1. You try every way you want. You do not get 4x, do you? Okay. So with conventional method where we factor the trinomial, if you cannot factor the trinomial, you are done. You're stuck. But guess what? With completing the score method, you can actually find the solution. Does that make sense, guys?
Yes.
And not only that, sometimes you try to factor, right? And what if you miss one of those possibilities, right? Then you may not be able to factor, right? You may not know how to factor, but using completing the score method, it'll still get you the right answer. So completing the score method will get you the solution every time, even if you don't know how to factor. So it actually works algebraically. You don't have to guess all these, you don't have to try all these possibilities. You guys remember how we look at all the possibilities and so forth? Okay? So let's do this problem, example 4. So you have a problem right now. This trinomial is not a factorable trinomial, turns out. right? But even though it's not factorable, we can solve. Now that we have this tool, which is called the what? Completing the square method. But, anybody see any problem with this one? Raise your hand if you see a problem for this one. Yes?
It's hard to get a perfect square because it's 3x.
Yeah, look at my leading coefficient, it's 3. Oh man, maybe we can't do it then.
Divide by 3.
Yes. Guys, that's right. Listen. Very good, very good. I'm glad you're, listen. Class. You are absolutely correct. When you are trying to complete the square on the left side, you cannot really do this if your leading coefficient is not 1. But since we have an equation, right? We have both sides, so why not then just simply, there's a very easy way to get that coefficient to be 1 just by dividing both sides by that coefficient. In this case, 3. So why don't we just divide both sides by 3? So write this down, guys. This is the most important step when you are completing the square. Must make the coefficient of the x squared, the leading coefficient, to 1. Otherwise, we cannot use that pattern we just studied. Does that make sense? And this is very easily done. Whenever we have an equation, you could always make that coefficient, leading coefficient of the x squared, to equal to 1. Just simply dividing both sides by that coefficient.
So you would divide 3 first before adding 1 to both sides.
Exactly. Because this is a step, if you don't do this step correctly in the very beginning, you will not be able to complete the square. Yeah, some of you will want to just add 1 and so forth, but you don't want to do that right now. You want to make the coefficient equal to 1. Question?
Could you add 1 and then divide by 3? Or would that just make everything harder?
It's really the same thing, but I believe this is the most important step. Okay, if you add 1 and so forth first, then sometimes people forget to divide. You know what I mean? So do this first. Trust me, this is better. So when you do it this way, your leading coefficient is now 1. John, what do I get? 4x. Don't you have to divide each of these terms by 3 if you're dividing the whole left side by 3?
4 over 3.
Good. 4 over 3x. Good. Equals 0. 0 over 3 is, right, 0. So please be careful. Please remember that you have to divide the whole, each of these terms, right, by 3. You ready? Then, after this, Anais, guess what we're going to do?
Plus 1/3?
Yes, add 1/3. That's when you want to add 1/3. Does that make sense? Now that we have the coefficient equal to 1. Does that make sense, Anais? Okay. So, exactly right. We add 1/3 to both sides. Now, class, do we know, Cameron, what to do? So look at the left side. We don't have a perfect square. So the reason why we remove that 1/3 to the right side is because you don't have a perfect square trinomial, right? So let's make it. In other words, let's complete the square. You see, that's why it's called complete the square, right? Method. Let's complete the square on the left side. What do you think we need to do? What's my b this time? Raise your hand if you know what my b is. My b is, yes, Savannah? 4 over 3. So what number then do I need to add so that the left side becomes a perfect square trinomial? Kyle?
2 over 3 squared.
Right, where did you get 2 over 3?
It's half of 4 over 3 squared.
Exactly. You just do b over 2. What is 4 over 3 over 2? That's same as dividing by 2, which is multiplying by 1/2. So you get 4 over
9.
4 over 9. You get 4 over 6 because you're multiplying by 1/2. So don't you get 4 over 6 squared? If you're gonna add 4 over 6 to the left side, guess what? You must add 4 over 6 to the right side. And Emily says, wait a minute, what is really 4 over 6? 2 over 3. Do you think it's best to simplify this before you kind of go on? Always what, guys? Simplify. So, go ahead, keep going, and then now I think I believe you can figure out the answer. Go ahead, keep going. Ask each other, help each other out, okay? Ask each other questions. So, by the way, you know, I found something interesting. A lot of you, after this step, you actually multiply the 2 over 3 square on the left side. Do you think that's a good idea? No, why not, Maddie?
Because then once you get 2 over 3,
No, That's not the reason. Why do you think I don't want to? On the right side, yes, you need to multiply this out. You get 4 over 9. Hold on, listen. How come it's not a good idea to actually multiply this out on the left? Yeah, Judy? Kristen?
Because you're just going to make x plus 2/3.
Yeah, this trinomial, right? Doesn't that just become x plus 2/3, the same number that you're going to square? Why are you going to square this? You know it's going to be 2/3 right here. Does that make sense? Squared. Equals to some number on the right side. By the way, some of you are saying, what, doesn't this have to equal to 0 every time? No, that's when you're trying to factor the left side. We're doing another method here. Does that make sense, guys? The right side does not have to equal to 0 every time, unless you're trying to factor the left side. Right? Here, you couldn't factor the left side. That's why we're doing all this different method. Right? That's why we're using the square, accompanying the square method. Does that make sense? Do you guys see what I'm trying to say? Yeah, you don't need to multiply this out because you know it's going to be 2/3 here. Right? Why do this? Why do double work? Okay, so then, by the way, on the right side, why do you think I'm multiplying 1/3 by 3 over 3? Yes, Lara?
Wait, so where did the 4 and 3x go?
Where did this go, guys? 4 over 3x. Lara, I'm trying to. Isn't this perfect square trinomial? That's why, yeah. That's why we did all this work, right? So that the whole thing on the left side is squared. Yeah, why in the world did I multiply 1/3 by 3 over 3? Anybody see why I did that? Yes, Tali? Yeah, don't I want to simplify the right side? And if you want to simplify the fractions, don't you need a what? Common denominator? So Elizabeth, did you guys get 7 over 9 on the right side? Good. Sarah, what do you think I should do next? Yes, now, class, am I ready to square root both sides now? Ellie, tell me what to write. Yes, very good. You even simplify that. So I first get square root of 7 over 9, right? Positive or negative. But could I leave right now? Is the right side simplified? No, because your denominator has a square roots in them. This is really square root of 7 over square root of 9. Well, thankfully, square root of 9 is what? 3. So you could get rid of that square root. Right? Isn't that right, guys? Now, Matthew, am I done? What do I do next? Yeah, I subtract 2 over 3. Do you think I should write that after the square root or before the square root? Before. Okay. So I wrote this down as negative 2/3 plus or minus square root of 7 over 3. Is this the best way to simplify or write this, or do you think I should write it as a 1 fraction? 1 fraction. And thankfully, I have a common denominator. What if I didn't have a common denominator? Then you make it into, right? You use the LCD and make it into common denominator. And how many people got this as the answer? X equals to negative 2 plus or minus square root of 7 over 3. And how many numbers does this represent? 2. So, somebody tell me, what's the smaller one? Laura? Oh. Okay. Yes, Kobe?
I got negative 2 minus rad 7 over 3.
Good. That's the smaller one. What's the bigger solution? Negative 2 plus rad 7 over 3. There you go. Questions? It was 7 over 9 right here, but it was square root of 7 over square root of 9. What is square root of 9? You have to simplify that, right? Because you don't want denominator to be square root. Have square roots. Any other question? Do you see how we get 2 solutions? Do you think you could do something like this on your own?
Yeah.
Okay, go ahead. Let me give you this. Everybody try this one now. Example 5. Now listen. Do you think I'm ready to... This time they were nice. They even moved the number to the right side for you, but are we ready to complete the square? What is your very first step here? Must divide both sides by 2, not 4, 2, so that the leading coefficient is 1. Right, Derek? I have 2x squared. Don't I want this to be 1x squared? So you got to divide both sides by 2 first. Go ahead, everybody try. So first, did you all divide both sides by 2? And get x squared minus 5x equals to 23. Like I said, this time they're nice. They put the number on the other side. Now, my b is negative 5. So did you all add both sides by negative 5 over 2 squared?
Yeah.
When you do, then the left side is a perfect square trinomial. That's why we complete the square, right? So we get x minus 5 over 2, whole thing squared, equals to, you get 23 plus 25 over 4. Well, I'm going to make sure that I have a common denominator. So multiply 23 over 1, right, by 4 over 4, which is 1, right? So I get 92 over 4 plus 25 over 4 on the right side, don't I? Don't I need a common denominator of 4? So you gotta multiply 23 over 1 by 4 over 4, don't you? So that you have a 4 as a denominator. Then you get square root of 117 over 4. Again, thankfully, the denominator is a perfect square. So I get x minus 5 over 2 equals to positive 1 over, yeah, plus or minus square root of 117 over 2, because square root of 4 is 2, right? Am I done? No, I need to add 5 over 2. So then how many people got this? 5 over 2 plus or minus rest 7 over 2? Almost. If you leave it this way, yes, you must. But even here, you're not done. Why not? Raise your hand. Shh, raise your hand. Yes. Well, yeah, there are two solutions. This does, but 117. Am I done simplifying the square root of 117? 117 is what? 3 times 39, 3 times 13. It's really 9 times 13, isn't it? So guys, make sure if you have a square root, you must simplify that, right? It has a it contains a perfect square of 9, doesn't it? So you gotta simplify. Then you get, yes, two solutions. 5 minus 3 over 13 over 2, and 5 plus 3 rad 13 over 2. Any question? You guys got that? Okay, please simplify always, right? Always simplify. If you have square root of 117, you gotta, note that there is a perfect square in it, okay? Good.